triangles.
Okay, that's what I thought. Chapter 4?
Yeah, chapter 4.
Okay. Well, let's talk about triangles. Let's talk about terminology. What's an equilateral triangle?
All equal sides.
Well, that's the definition, is 3 equal sides, using those hash marks. But it turns out that that also has to be 3 equal angles. Because remember that the angle opposite a side of a triangle, if it's the largest side of a triangle, it has to be the largest angle. In other words, if I draw a triangle like
the same
that,
size line, they're all the same size angle.
yeah, that angle is the largest angle, that's got to be the largest side. So if I have 3 equal sides, I have to have 3 equal angles also. About isosceles. What is an isosceles triangle?
Is that 2 equal sides?
Yeah, this is the one you're going to run into more frequently. In other words, when you take your ACT test or SAT test, they're going to ask you a lot of isosceles triangle questions. They won't ask you very many equilateral. And this just means 2 sides are equal. Now, there's something very important about isosceles triangle. It's not just 2 sides are equal. What else? The angles opposite each of those sides are also equal. Now, first of all, tell me if you have any problem whatsoever determining the angle opposite a side. What is the side opposite angle C in this drawing here?
Second. By the way, controls opposite C, be BA.
Okay, what's the side opposite angle A?
BC.
And opposite angle B?
AC.
Okay. You're good on those. So that's always true of an isosceles. And it just turns out that isosceles triangles show up a lot in geometry. What's a scalene? This is not a very common term, but what is it? A scalene triangle. What's that?
No sides or angles are equal.
Yeah, something like that. No equal sides, no equal angles. The reason that doesn't show up is because that's not a very interesting triangle. In other words, it's the triangles that are interesting from a mathematical point of view are isosceles triangles, right triangles, things like that. All right, what's an acute triangle?
Acute triangle. Triangle with, I don't know.
All 3 angles are acute. In other words, any triangle is an acute triangle if you're just looking for one acute angle.
Okay.
In other words, every triangle has to have at least one acute triangle, or one acute angle, an angle less than 90 degrees. But any triangle like this that has all 3 of them, in other words, these aren't necessarily the same. They're 3 different angles, but they could be like 50, 60, 70. So all 3 angles are acute. Again, that doesn't come up very much, but it's worth knowing terminology-wise. Equiangular means all 3 angles are the same. What's another name for this?
Equilateral.
Equilateral, exactly. And finally, the one that has the most math associated with it is a right triangle. Almost all of trigonometry is based on right triangles. So this one you're going to encounter a lot. And the main things about a right triangle, there's one and only one 90-degree angle. The side opposite the 90-degree angle is the hypotenuse, and it's the longest side of the triangle, obviously.
Right.
These two angles are complementary. They add to 90. The magic number in geometry is 180, but when you're looking at the two acute angles of a right triangle, you're talking complementary. They add to 90.
Okay.
And finally, an obtuse triangle is merely what? What would be the definition of an obtuse triangle?
Triangle with one obtuse angle.
Yeah, it can only have one. In other words, unlike an acute triangle, it's only an acute triangle if all three angles are acute. An obtuse triangle only needs one and can only have one. In other words, because the angles have to add to 180, you can't have two angles that are greater than 90. All right, a couple of things we've talked about. What are the sum of angles 1, 2, and 3?
180.
What are the sum of the exterior angles? 1.
360.
Yeah. And that's no matter whether it's a triangle or a rectangle or a polygon. The sum of the exterior angles is always 360. What about this? What is true in that drawing?
3 and 4 equal 180. 1, 2, and 3 equal 180.
Keep going. You almost got what I'm looking for. Both of those statements are true. What's 4 equal to? Notice what we have here. Let me work you through this logic. 1 plus 2 is supplementary to 3, correct?
Mm-hmm.
4 is supplementary to 3. What has to be true between 4 and 1 and 2?
1 and 2 are equal to 4.
4 is equal to 1 plus 2. That's called the exterior angle theorem. You could always figure it out. It's not one that you have to memorize in order to do geometry, because you're always going to be able to work out the numbers, but it's one that will speed you up sometimes. In other words, if I gave you the following problem, oops, 2x plus 10, excuse me. What is x equal to? Using the exterior angle theorem. Tell me what 2x plus 10 is equal to. Angle 4 is equal to 1 plus 2. In other words, angle 4 is always equal to the sum of the two angles that it's not a linear pair with. Right?
Yeah.
So, taking that logic to this diagram, what is 2x plus 10 equal to?
I don't know.
Well, it's equal to this one plus this one.
Oh.
Notice that the similarity. That's 4, that's 1 plus 2. In other words, the two angles of the triangle that it is not a linear pair with, it's a linear pair with 3, which means it's equal to 1 plus 2, or in this case, that's x plus 65. Solve that for x.
X equals 55.
Yeah. And notice that that problem was a whole lot easier because we knew that exterior angle was equal to the sum of those two angles. Not sure how we would have done it had we not known that, but okay. Here, do this problem for me. What's x? The way you always solve these geometry problems is you put it into an algebraic equation. That's always step one.
So, would it be 30?
Yeah. In other words, x plus 2x equals 90 because they're complementary. That's 3x equals 90, x equals 30. All right, let's talk about congruent triangles. Congruent triangles are triangles that are basically equal. By that I mean they have the same three sides. That's what these marks mean, right? In other words, this side is not equal to this side, but this side is equal to this side over there.
Mm-hmm.
They also have the same three angles. And what doesn't matter is their orientation. In other words, if I were to draw that one like that, and I were to draw that one like that, they're still congruent. As long as I know that that side is equal to that side, and that side is equal to that side, and that side is equal to that side. And in fact, all I need to know is that all three sides are equal to one another, and that proves congruency. In other words, it's one thing to know what congruency is, but it's another to prove it with a minimal amount of information. And you almost always need three pieces of information. Okay? In other words, if I tell you that three sides of a triangle are the same three sides of another triangle, then that proves congruency. And what's the difference between equal and congruent? It's actually a subtle difference. I use this drawing to illustrate it. In other words, I would say that is equal to that, but I might not say that is equal to that because they're oriented a little differently. But what is true is that at the bottom, this is congruent to that. And congruency means equal sides, equal angles. But if you're looking for a difference between the meaning of the two words, this probably illustrates it best. It would be hard to say those two triangles are equal because it doesn't account for the fact that this one's been rotated. Okay, now, if I have two triangles that have the same three angles, does that make them congruent?
Yes.
Well, let's draw a picture. Make this one 60, 50, and 70. Over here, I'm going to draw a triangle that has 60, 50, and 70. Same three angles. Are those two triangles congruent?
No.
No. They're similar. There's two words, congruent and similar. Similar means same shape, same three angles. But it doesn't necessarily mean the same three sides. But it does suggest a proportionality. Here, let me label these sides something that's believable. That has to be the smallest. That has to be the next smallest. That has to be the biggest. So if this triangle over here was similar to this triangle, then its sides are going to be proportional. You with me?
Mm-hmm.
You're not going to get the similarity for a while, but it's important that you understand the difference between congruent and similar immediately. Similar just means same shape. Congruent means pretty much same size and same shape. Now we have a bunch of rules to tell us whether things are congruent or not. And in fact, let's take this problem here. I'm going to jump. I'm looking in the book and I'm not quite sure why they put this problem in here at the beginning of a section that says congruent triangles, but I kind of have a feeling I know. Let me see if I can do an adequate job of drawing it. Hold on. Let me label it. All right. No, hold on. I'm not done. Sorry. In this diagram, these two figures are congruent, which is what this symbol means. It doesn't mean equal, it means congruent. Okay? And the problem is to solve for x and solve for y. Well, hold on, I might have left some stuff off. I did. That's 10. That's it. So, first of all, you have to figure out which are the congruent sides. Tell me which sides are congruent. What's the side in the figure on the right that is congruent to PN?
EF?
Yeah, and you know that because they're both the longest sides. So I can say 10 is equal to EF. And I can now say it's equal because we're talking about a line, or a line segment. Which side is congruent to LP?
FG?
Yeah, again, it's the shortest. So which side is congruent to GH?
MN? Or, yeah, MN.
Not MN. What's
Oh, LN?
Yeah, hold on. Yeah, not the way I drew it, but yeah, I'm sorry. I didn't draw this very accurately. But yeah, LM. In other words, one way to figure out if you base everything on PN, which is the side opposite to EF?
Okay. GH.
Right, so GH has to be the side that's congruent to LM. And that's probably the best way to do it. Rather than to try to figure out what the second longest side is, figure out the side opposite this longest side. In other words, it's not that easy to do this problem. It's really rather difficult. It involves a rotation in space, and then you have to match up matching sides. Well, if I start with LM as opposite the PN, and I know that PN is equal to EF, then whatever side is opposite to EF is opposite to LM. So I can say that LM is equal to 2x minus 3, which is GH, and they've given me 8 for LM. So that allows me to solve for x. Is x going to be equal to? Never going to pass up an opportunity to practice your algebra.
545.
Okay, let's mark it 11 halves. Because that's how we got it, was we started with 11 and we divided by 2. And in fact, I'm going to make a radical statement to you that the improper fraction is a better way to give an answer than a proper fraction. And part of that is because when you get to trig, it's all about ratios. So in trig, you would always give the answer as 11 halves, not 5.5, not 5.5. It's the same number. I'm just telling you that sometimes the improper fraction is a better way to state things. And as far as 7y plus 9, which angle is that?
PNM 72.
Correct. So I have 72 equals 7y plus 9. Do the algebra on that.
Maybe 6 or 62 divided by 7.
Well, let's
Maybe 10.
hold on. We'll subtract 9 from both sides.
63. 7y divided by 7 is 9.
There you go. Always remember that when you are looking at a number whose digits add to 9, that it's divisible by 9. Both of those numbers are divisible by 9. So when you're looking at dividing it by 7, the answer kind of has to be 9, right? In other words, if that number is divisible by 9 and we're dividing it by 7, then the answer is going to be 9. I mean, if it's an integer. I mean, I guess that's not totally true. If I were to divide it by 8, it wouldn't be 9. It would be 63 divided by 8. But if we know it's an integer, and with these kind of problems, you always know the answer is an integer, just because they're not yet at a level where they're giving you problems that have fractional answers.
Mm.
Okay. All right, that's a good place to stop.
Yeah, thank you very much.
You're welcome, Cole. Have a good week. I'll talk to you next Monday.
That sounds good.